Hi, thank you everyone for coming to our Collections.compare talk. And it's an interactive session. If you would like to ask questions, please do. Otherwise, just speak it loud enough that we can repeat it back as it's being retaped, okay? And I'll briefly talk about our speakers first in alphabetical order. Donald, please.
Hey, so welcome everyone. My name is Raab. I'm a managing director at Bank of New York Mellon, based in Jersey City, New Jersey. For those that don't know me, I am the creator of a little framework called Eclipse Collections, which means this talk will be completely unbiased. Also as a member of the JSR 335 expert group, which was the thing that got lambdas and streams into Java. And I've been at various conferences. This is my 4th Java 1 speaking. I've been at Devox, JVM Language Summit, GIDS, so on and so forth. So.
Yeah, I'm Leonardo Lima, and I work at Vitecom. It's a Brazilian company that does industrial IoT. And I'm currently living in Austin, Texas, and I was awesome. And I'm currently the CTO at Vitecom, where I led software development, and that's how we got this talk started. Was they trying to say, well, you should use our framework, and I said, why? And then how you compare collections. That's how we got it started. So my company is also a representative at the GCP Executive Committee, and I did lead a JSR 363 units of measurement.
Hi, I'm Nikhil Nanivadekar. I'm a vice president at Goldman Sachs. I'm based out of Salt Lake City, and by academic education, I have a master's in mechanical engineering. I'd actually not written even a hello world in Java till July 3rd, 2012. July 2nd, 2012 was my first day at Goldman. So that's my journey. Starting March of 2017, I started owning Eclipse Collections, the framework which he created. So now it's pretty much my responsibility to make sure I only merge those things which make sense for the framework. And that's the reason why all 3 of us are here, because Leo comes from a background where he does not want to use Eclipse Collections. We want him to use Eclipse Collections, and then it ends up happening where he's showing us what all things are available in other frameworks, all right? And that ends up like sort of having a nice, a symbiotic relationship, I should say, where we are looking at other frameworks and actually comparing. And that led to this talk.
Yep. So again, my background is Java developer. I've been developing for 12 years, more than him, less than him. And I've been using Java U2 collections for forever, ever since they came out. And so I always use it, and I don't know about you, but I like my projects to have as little dependencies as possible. It's less code to worry about. So I said, well, what's available in the Java U2 collections? And it's been around for a while, so it's since '98, and with a very basic but critical support for collections. And it has kind of 2 main interfaces, maps and collections. So they are different trees on this implementation. Collections is everything but maps, so list, set, queue, deck, queue, they are all collections, and they implement a collection interface. And maps are just maps. So the JDK provides a bunch of basic implementations of these interfaces, and when Java 5 came out with concurrency, they released the concurrent versions of them as well, so you can use them on a concurrent code. And they do have some algorithms for doing basic stuff with a collection, so like sorting, shuffling, data manipulation, like adding, removing, searching, and all that stuff. And some people are really new to the language, and that's like, if not the first, the second thing you should do after Hello World is to work with a collection. And they have very good tutorials on Java website on Oracle, and here we have links for their simple and the concurrent tutorials. And I think it's very nice to show how the collections framework evolved since it was launched, so that we can see where we were and how stuff evolved over time. So again, almost 20 years of evolution. And you can see that from Java 2 to Java 5, so from '98 to 2005, not much has changed. But then Java 5 came with generics and for loops. Sorry, for each loops. And that brought a lot of improvement on code readability and doing more with your collections than you thought it was possible. With the generics, you didn't have to do so much casting, and they added some concurrency utilities as well. So it was a huge improvement that I saw my reason to move to Java 5 was generics, and I loved it, and I stayed it forever there because it was like really good. And then on Java 6 they added a little bit more stuff, and then Java 7 not so much, and then Java 8 was like another major overhaul. So it took like 7 years from Java 2 to Java 5, more 7 years, and like 9 years to get lambdas and method references and a bunch of other stream interfaces, which I guess you all, if you didn't see last year's and the years before, Java 1s, there was a lot of stream talks and how to use streams on these libraries, in these interfaces. And in 2009, in Java 9, 2017, they launched even more stuff on the API. So I saw a huge line on immutable collections for Java 9, and this is something we're going to talk about in this talk. And still, they are not as wide-reaching as possible. And I'll show you how the needs of why I use something that is not Java U2 collections. So, for example, sometimes you're comparing things and you want to have them sorted by their name. So if you have people and you want to tell you how many peoples are with the same first name. And then you want to iterate over the people with the same name to show their last names. And then we'll do a very nice table. How do you do this in Java U2 collections? You have to have a map of string, of list, or of set, of string again, or of object. And as you do these more and more and more, you get a very long bunch of diamond operators all around. And that's really not clean. And on other collections, you have multi-map. That's why when they said, hey, you should use our collection, I said, well, how do you guys handle multi-maps? I know that Apache Commons collections, which is the other library that I usually go to, they have that. And so that's how we got started talking about. So what are the other collections available? What else is out there that people can use with Java 5, 6, 8, 9 that can be used to address the collections needs? And I think that's, we chose 4. I think these are the 4 more commons. And we compared to Java 8 collections. We didn't had time / experience on the Java 9 collections to do a proper work of updating this presentation to Java 9. But Java 8, besides Java, we have Apache Common Collections currently on version 4.1. That's what I used most outside of Java. Eclipse Collections, that was before Goldman Sachs Collections. That's why Nikhil is taking care of it. And formerly Don was working with them, and he brought it to the open source, which is a really nice move. And Google Guava and Vravor, I don't even know if I say it right, but it was Java's lang before. They both have collections frameworks. They do other things, not just collections, but they do have strong collections. So sometimes I was using Guava for something else, and I needed a multi-map. Boom, there it was already. I didn't have to bring Commons Collections just for a multi-map. So again, we're going to have this posted, and this has very good links to their user-guided documentations. And I think that's one thing you have to consider. If you're looking for something that doesn't have a good documentation, you should steer away, because it means normally that no one is using that. And I think these guys and all these others are doing a very good job in maintaining their documentation. And I think you want to explain now the evolution. I think you're the best guy to talk about this.
So I'm going to come down here, join you all down here. So if you look, since Java 2 came out and we first got the Java Util Collections library, initially in the space you had Java Collections and then had Apache Commons. But if you fast forward through the last almost 20 years, what you see is that there's a lot more stuff going on in the collection space, right? And really since Java 8 coming out with the addition of lambdas, now there's the ability to do a lot more interesting things, right? And you're seeing, I think, kind of a revival in the collection space in terms of functionality that's available. So, all the way, since Java 9 has been released, if you look this year in 2017, you've got, 3 new versions of Guava. You've got 3 new versions of Eclipse Collections. You've got now Java slang has become Vaver, and you've got Vaver point 0.9, and actually they're working on, I think, the current snapshot of Apache Commons, 4.2. Actually, there's work actually going on there. So you've seen this increase in the space, and to Leo's point, there's a lot going on there, and there's a lot that of stuff that's not available in the JDK collections today, and other things are providing those types of features. So what we're going to do today is actually take these 5 different frameworks, so Apache Commons, Guava, Eclipse Collections, Vaver, and Java 8 streams, and actually do a comparison. And the domain that we're going to use during this comparison is pretty simple. It's a deck of cards. So we have a card. Everybody know deck of cards, like playing cards? You play Go Fish or Solitaire, any other game? So, so what do you have? In the domain you have, and this is the common part of the domain's on the bottom. You have card. Every card has a rank and a suit. So rank is like ace through king, and a suit is spades, clubs, diamonds, hearts. And construction of cards is pretty simple. It's actually just the Cartesian product of those 2 things, right? And it's interesting. One thing I like to say usually is, you see I came down off of the stage. It's very apropos to this domain. I was shuffling the collection of speakers that we have, right? Okay, sorry. So anyways, I digress. So the problem statement we're going to talk about today, we have a bunch of different operations that we're going to actually use. And if you look in the deck of cards itself, the thing that's going to change between the frameworks, we're going to store the cards as an immutable list, and then we're actually going to group the cards into an immutable list multi-map. Now, if a framework has the types, we're going to use them. If not, we're going to simulate them with the types that are available in the framework. So the first thing we actually have to do is create the deck of cards. And I said before, creating a deck of cards is easy. We have an enum of rank and an enum of suit. We just have to do the Cartesian product of those things. So we're going to show you what that looks like. Once that's done, we're going to store it into an immutable list. Then we're going to group the cards into an immutable list multi-map. Then we're going to do different operations. We want to get the number of cards by rank and by suit. And we're going to return those either as a multi-set or bag, depending on the types available in the frameworks that we're using. And then we're going to deal the cards. And now to deal the cards, we have to shuffle them first, and then we're going to deal the cards out of the deck. And we're going to return the cards as an immutable list of sets, 5 cards each. Okay, so on this slide, what you see is what the definition of each of the deck of cards are. So once again, I told you, like, you have the common domain of card, rank, suit. That doesn't change. The only thing that changes is the deck of cards. So what we have, starting with JDK, you see we have the definition of JDK deck of cards. We define a list, and then we have of card, and then we have a map of suit to list of card, right? So that's where we're going to do our grouping. For Apache Commons, we've got a list of card, and then Apache Commons actually has a multi-map, so we're going to use the multi-valued map from suit to card. With Eclipse Collections, there's an immutable list, and there's an immutable list multi-map, so we're going to use those types. Similarly, in Guava, they have an immutable list, they have an immutable list multi-map, we're just going to use those types. With Vaver, we're going to use list and map. There's no multi-map type. What's interesting is, in the case of both JDK 8 and Apache Commons, you see with the list interface, we don't have an immutable list in either of these frameworks, so we have to actually, we're going to simulate it via unmodifiable collections, right? So we're going to actually create something and wrap it as unmodifiable. In Vaver, the types that you see here, list and map, these are not the JDK types. So they have the same name, but they're actually the Vaver types. They are immutable by default. So there's no immutable in the name, but they're actually both immutable types. So first thing, we're going to do the Cartesian product. So as I was working through this code, and it's funny because we've actually given this talk now, I think this is the 3rd conference. The first 2 times that we gave it, we used a completely different set of data structures. We used a mutable sorted set and a mutable sorted set multi-map. So we wanted to try it out and see, like, hey, if we try change it to a mutable list, what it's going to look like. Now, as I was working through solutions on this stuff, what I realized when I was doing the Cartesian product first thing was I realized, hey, it's Cartesian product, so I can, I should actually use that. And then what I realized is there's this common code that I can actually put in one place and share across a bunch of the solutions. So what I did was on the card class itself, there's a stream cards method, which I then call another method on a card called Cartesian product. And I take an enum set of ranks, so both of these are enums. So I take an enum of the ranks, enum set of the suits, and then I actually implement Cartesian product here. So this is what a Cartesian product implementation looks like. You basically do flat map with map, right? Once we do this, when I call stream cards, I'm going to get a stream of cards out, and then I actually have to put that into an immutable list. With Eclipse Collections, we actually have a Cartesian product method, and actually this is a more recent version of that, where our old Cartesian product used to return a pair object, right? And I wanted to actually make that flexible enough so I could actually return the type I wanted, so I actually now have a Cartesian product that takes a function. So we just use that with Eclipse Collections. So I can say like, card new, the method reference or constructor reference is going to get mapped to a function, and then I can just call Cartesian product. Here, we return.
Recorded, so it has to go through the mic. So sorry. So, and I think this, and she said like now we have it, and that's because of us. As like we were talking and we were evolving the API, and that's what I like about open source projects, that everyone can get started in using, and it's a really good way of you helping open source developers is to give them use cases. So if I never contributed one line of code to Eclipse Collections, but I helped them give him like use cases and how do you do this, and let's change the documentation to show better how to do that. So I think that's a really good thing that people don't normally say, and you get to learn and work with people that you would never work together. And like they work in banks and I work in IoT, so it has nothing to do, but we are working and learning with each other on this project. So I think it's really nice, and if you guys are not involved into any open source project, even just reading documentation and trying to your use case, you should.
Okay, with that, I'll hand it to Nikhil.
So we are going to do, I know, but it's easier. So while going through the slides of Collections.compare, we are not only going to compare the way the code looks like, but we want to have some metrics around it. And we are going to look at two basic metrics. One are the JMH metrics, and the other ones are memory tests. So looking at the performance benchmarks, it's Java micro harness. It's available in the open JDK, and what JMH does is you have a few options in which you can run your benchmarks, and you can either run it as operations per second or you can run it as second per operation. So, I mean, if you want to run it as operations per second, you can be rest assured that, hey, the higher the better. So basically, if the number is higher, that means that particular collection is better. And it's very important for any benchmark, especially a performance benchmark, to know on which machine it has run. So we tried to keep it on that exact same machine, which was my laptop, and it's a 4-core Intel i7, and we ran it with 50 warm-up iterations and 30 measurement iterations on 3 forks. So it was basically 90 iterations on which these numbers are based on. So the next metric which we're going to look at is the memory test. As a part of JDK 8, we have an internal class in Nashorn called as object size called calculator. The object size calculator gives you the size of the complete object. So if you have a list or a map, then it will also have the memory of the objects or the elements contained inside that list. So part of the thing which we are doing in the memory test is we take that size and then we subtract the size of those particular elements so that all the sizes that you will see up there are of the data structure. I'm right?
No, we're actually including the cards.
Okay, so
yes.
They are using all the same objects.
Okay,
Yes.
so they're using the same object, so it's apples to apples comparison. So for memory tests, it's smaller numbers the better, because you want to use less memory, and we test the size of the data structures created in each code example. So looking at the actual metrics, so the first one was ImmutableList. So this was for the create the deck of cards, the Cartesian products operation. So you can see in an alphabetical order from left to right, you have Apache to Guava. And all the frameworks are pretty much comparable, but Eclipse Collections is about 225,000 operations per second. So it's slightly edging up, but it's not like a very significant change. And partly one of the reasons for that is whenever we create an immutable list in Eclipse Collections, you have to first go from the mutable side to the immutable side.
Yeah, and let me just say something with these performance tests that we're showing as well. When you see something that shows 187,000 operations per second, this is obviously not going to be a common use case you're going to be looking at to base decisions for your application on, right? That's a lot of operations per second, right? This is all in memory. This is never likely to be a bottleneck for you, right? So the differences, they're interesting to look at, but I wouldn't say like, hey, I have to use that because my code will somehow go faster. This may not have any impact to you at all, so.
Then this is something which will definitely have an impact on you, though. It's the memory usage. So you can see that from left to right, again, it's Apache to Guava. And I'll keep on reminding that on memory side, on the memory test, the smaller numbers, the better. On JMH test, the higher numbers, the better. So it's like inverse. This is the memory side. So the lower numbers, the better. You can see that Eclipse Collections and Guava are pretty much at par at about, exactly at 2,776 bytes for the whole deck of cards. But the salient point is we are not starting at 0 because we need to make it comparable. So it started at 2,700. So it's not, they are they have an advantage, but again, not that big of an advantage. And we'll see why in the subsequent slides.
Yeah, so what I'm going to do now is actually show you the code that you have to write to do both operations, doing the Cartesian product into an immutable list, and actually then doing the group by. First thing, we're going to look at JDK and zoom in on the code that we actually have to use just to create the immutable list. So what we're going to do is we're going to initialize the cards variable by calling card stream cards. So that gives us that stream of cards, doing the Cartesian product, and we're going to sort it. So each card actually has it defines implements comparable. So it'll get sorted in the right order. And then we can actually call collect, and we use a collector to list. And then we're actually wrapping this with an unmodifiable list to make it effectively immutable. What's interesting is I've tried this a number of different ways. You can actually try and use like collectors with collecting and it works and it actually looks kind of more fluent, but it actually winds up being a little bit messier on the screen. So I went with basically the simplest thing I could show here, which was actually doing the wrapping on the outside. With Apache Commons collections, similarly we're going to use the stream cards, and I'll zoom in, and sort them, and we use the same collectors to list from the JDK. Apache Commons has a class called listUtils, and we're going to call listUtils unmodifiable list to actually wrap the list to get pseudo immutability. With Eclipse Collections, instead of calling stream cards, we're now going to call lazy cards. So lazy cards gives us a lazy iterable, and then what we can do on that is use the API for 2 sorted lists. So we've now got a sorted list that's mutable, and we call 2 immutable, and now we have an immutable list getting stored into cards. With Guava, if we zoom in, we get the stream cards. We then call sorted on the stream. And then there's a special collector that Guava gives you on immutable list, the class. There's actually 2 immutable lists. So you can do sorted.collect and then pass an immutable list to immutable list. With Guava, we zoom in. We're taking the same stream cards, and then we call sorted again. And then Guava also has its own collector on its list class, which you can call list.collector, and that actually gives you the immutable list. Okay, so that was how we create the immutable list, right? Pretty simple? Okay, next thing we're going to do is group the cards by suit in an immutable list multi-map.
So first I want to explain what exactly a multi-map is. So like Leo mentioned before, Apache had its multi-maps and everything. So basically a multi-map is a multi-valued map. So it's going to have one key and it's going to have a collection of values. A normal map is going to have one key and one value, but a multi-map is where it has multiple values. thereby the name. So if you look at the group by operations, you can see that to get a particular multimap, you're essentially grouping by the key. That's why we're mentioning this to be a group by. And you can see that in a performance test, the higher, the better. So you can see that Guava is, the JDK is the clear winner. And partly the reason for that is JDK does not have an immutable multimap. So, and we will see much more in detail in the code decks. Whereas as opposed to that, Eclipse Collections as well as Guava have their multimaps. So does, I think that's it.
Apache.
So does Apache. And if you see again, the performance metrics are like JDK blows through the charts. I mean, they pretty much just go through it. And that's partly the reason because of the immutability aspect of it. But if you compare with the actual space used, then again, all the frameworks are pretty much comparable. So all I'm trying to say out here is if you're looking for an immutable, a really, really immutable multimap, then you have to be cognizant about both the sides, the performance as well as the memory side. On the memory side, it's pretty much comparable out there for all.
Okay. So now we're going to focus on what the groupBy code looks like, right? So once again, we're trying to create an ImmutableList multimap, and since we don't have that type available in the JDK, we have to make sure that when we create the map with the lists, that the map is both unmodifiable and the lists are unmodifiable, right? So we take the cards, we then, and you can see we're using the collectors collecting and then here. So we do a grouping by, we group by suit, and then we map, based on identity, and have to do collectors collecting and then create the list and actually make sure that each individual list inside gets wrapped in an unmodifiable list. And then that final collecting and then. This is where I told you before I used that, remember I used collectors unmodifiable, or sorry, collections.unmodifiable list. I could have done that with unmodifiable map, but I wanted to show you like, this is what the collecting and then looks like, right? So you got those two options. Either I could have wrapped the whole thing in a call to collections.unmodifiable map, or I can use the collecting and then, which does it as well. I could have zoomed in here, but it's funny because on this page it doesn't actually get much bigger on the slides. It doesn't really help. With Apache Collections, what we actually get to do is we create a, yes? You want to go back? Okay, we got a stream of cards. First thing we're going to do is say collecting and then, which means we're going to collect something and then we're going to do something to it after we collect it, right? That thing that we're going to do is, first we're going to do a group by, right? So we're effectively going to create a map of lists. The keys in the map are going to be the suits. Lists are going to be the cards for that suit. And what we're going to make sure is that when we're collecting up those lists, yes, and the face that you're making is exactly the face you should be making.
He likes to rub
it. This is the intended
yeah.
response of this slide.
Yeah, so the point that they make to me is that this is long and this is hiding some implementation or characteristics from the interface,
Yeah.
or actually the other way around. It's exposing stuff so it's not really immutable. Because even though you have a modifiable list, you get a list that has an add method.
Yeah, you don't want to return a non-modifiable map that has mutable lists in it, right? Because then it's really not immutable, right?
Yeah.
The map and the list have to be
really
mutable.
complicated to do.
And I think this is a case where because you don't have a data structure and you try and do things through algorithms, it becomes more complicated, right? It would have been better served via a data structure.
And one more thing to add about the unmodifiable aspect of it is whenever you're doing something unmodifiable versus immutable, it's different. If you're going from a mutable side to the immutable side, then that's always an ON operation because you have to make sure you have a copy of the immutable, because an immutable list or an immutable collection has to maintain its state all over the place, as opposed to unmodifiable, where you just add a wrapper on it, and then all it's going to do is for all mutating operation, it's going to go on throwing at runtime. So you're comparing O1 versus ON, and that clearly shows in the performance benchmarks.
Okay, so fast forwarding to Apache Commons. So they do have a data structure here, right? And it's interesting because the list valued map that we create here using multi-map utils is a mutable multi-map. And then we iterate over the cards just using for each, calling put into the multi-map. So put on a multi-map has the effect of finding the key in the multi-map and basically adding to the list that's at that key. But then there's a utility class in Apache Commons called multi-map utils, and we can actually wrap the whole multi-map in an unmodifiable multi-value map, which is a little bit less complex than what we had before, still taking something that's mutable and then making it immutable at the end. So with Eclipse Collections, since we have an API for groupBy and since all of our methods are covariant, on an immutable list, a groupBy will return an immutable list multi-map, so we just have to say cards groupBy, card get suit, we get back the immutable list multi-map. Do you want me to explain this more?
Yeah, so that's their point, like their selling points. Like, if you need something that is not there, we put it there, and then we will use it, and we will use it,
yeah.
and please
and
use
remember, this was faster. This was faster, ran less time. This was slower, but it wasn't slower for me to write, right?
Yeah.
Okay, Google Guava. So. In Guava, there's a class called multimaps, which has an index, and this returns a very specific type. And this is the downside of using static utility. You can only return one type out of here. Our groupBy is covariant, so it's based on the type you're iterating over. Index always returns a mutable list multimap, but it works well here. So I can use multimaps index, takes an iterable, which we just pass in cards, and then we do card suit, and it's nice and simple. And it is a mutable list multimap. With Vauver, similar to Eclipse Collections, Vauver's groupBy actually returns an immutable map. It's not a multi-map, but it gives us the same effect. So I can just say cards groupBy, card get suit.
So in the interest of time, I'm just going to breeze through this one, because this is like one shot where you're seeing on the left is the deck of cards. So that's actually when you sort of superimpose, do some math, you end up of the two things on the right, you'll get that. But no, we actually ran the test. So there's no math involved in there. It's what the actual performance tests look like. So you can see that all of them on the left, to create a deck of card, is the sum total is same. All right. But if you look at the immutable list and the group, when I say same, it's similar. If you look at immutable list and groupBy, however, the JDK is breezing through, but it gets compensated because of the immutable list. Again, you're looking at modifiable versus immutable. So keep that in mind. It's ON versus O1. And we're going to, again, the memory is comparable. And one of the reasons why Vauver has the highest memory usage is because of the way their immutable lists are implemented, because they're linked list underneath the covers.
Yeah. Now, obviously, these numbers aren't interesting from your application perspective, but if you considered a deck of cards as maybe something that would be represented in your domain, maybe customer order, and you had millions of those things, right? What you can see then is that what is now measured in bytes on these slides could be measured in either megabytes, or if you had enough of them, could be who knows, gigabytes, right? Okay, next thing we're going to do is get the number of cards. So this should be a little bit easier. We're going to count by suit and count by rank.
So we have the basic concept called as a multi-set or a bag. So what that means is if you have one element, then how many of those elements are there in that particular collection. So for Eclipse Collections, we have something called as a bag. Apache has a multi-set and a bag. They're basically the same thing. Guava has a multi-set. The difference between each of these is our bag is actually implemented underneath the covers as a primitive map. So it's an object int map. And if you look at that's one of the reasons why the way we created, we pretty much are really fast, but that's really, really significant, or it's apparent when you see the memory test. Now these are starting at 0, okay? So for the whole counts by suit, for all our suits which are there, you end up getting the memory consumption to be just 408 bytes for Eclipse Collections. And the JDK and Vauver are at par, and Apache and Guava are pretty much at par as well. Then counts by rank. So again, same thing. Underneath, it's the multi-set and the bag difference. But the difference between counts by suit and count by rank are the number of keys that you will have. So that ends up impacting the performance test. And more so, it is very apparent on the memory test. But again, because Eclipse Collections' bags are underneath an object int map, we end up saving the most memory.
Okay, so I want to show the code for these performance stats, and what you see is if we want to count by suit, count by rank. With the JDK, what we do is we take the cards, we call .stream. We're then going to call the collect method on stream and use collectors grouping by collectors counting. Anybody seen this code before? No? It's the first time? Okay, this is, oh, Maurice, you've seen this code before. You've probably given this code in talks before, right? Maybe not with cards. So anyways, this is how you actually count something, right? If you want to count them by a particular key, so here we're counting the cards by the suit, and we get back a map of suit to long, right? Same thing for counting by rank. We still call the stream, collect, collectors, grouping by, use the different key. We're going to use card get rank, and then collectors counting. With Apache Collections, kind of interesting, Apache Collections has both a bag and a multi-set. They are the same thing, right? Just two different names. It historically had bag. Multi-set was introduced more recently, I think, since version 4. So I was kind of surprised to find it. So in this case, I used both because they were both there. Hey, I like one, I like the other, I like both, right? So what we're doing though here is we stream, we then map the attribute, either get suit or get rank, and then we collect into the target collection either the hash bag or the hash multiset. This is going to have the effect as we're adding into a hash multiset or bag, the data structure itself keeps track of the counts internally, so we don't actually have to specify the algorithm like we did with collectors grouping by collectors counting. With Eclipse Collections, and this is a new API, and to Leo's point before, as I was writing these, this talk for DevOps, I was like, it'd really be nice if we had a method called count by, because when I show people that you have to use as lazy collect bag to bag, what's as lazy, what's collect, and what's to bag, right? It doesn't make a lot of sense if you don't know what these things are, and I have to explain them to you. But I can show you a method called count by, and that actually probably conveys a little bit more meaning as to what's happening here.
Just a little.
Just a little. So we call this cards count by and specify what we want to count by, and we get back a bag of suit. Now, you may still have to ask, well, what's a bag? And you can imagine underneath a bag is a basically map of suit to some count, or in this case, in the other case, bag of rank, map of rank to some count. Now, Guava has a multi-set. They do not also have bags, so I only use multi-set. But here, same thing I did with Apache Commons. I iterate over the cards using stream, and I collect. And Guava has this collector on a class called multiset. So, and it's interesting. This is one of the things, as the creator of a collections framework, it's kind of interesting to put on someone else's pair of shoes and go into their collections framework and try and discover how to use it. And it actually helps you develop a little bit more sympathy and empathy to developers who have to try and discover your API, right? It's like, how do you find this stuff? And where's the documentation? And oh my gosh, like, nothing's available. Oh, it's too hard. I'm going to give up. So anyways, I discovered multisets existed. And you can do collect into multisets to multiset. You specify what you want to effectively count by. And you can actually here specify a count function as well. So I'm just mapping the element to 1. I'm counting by ones, and then into hash multiset. Now, Vavr was interesting. Vavr doesn't have a bag or a multiset. And it didn't really have a good way for me to also do the work in their own maps, so I basically just delegated out to using a Java util map. Now it's interesting, you see the problem here in that I was coding it in a class where I had a map that was Vavr's and a map that was Java's, and now I have to basically solve the problem of two things with the same name, and I have to use packages in the names on these methods. But Vavr has a method called collect directly on their type. And what it is, it's a shortcut to get to stream.collect. So they give you basically a shortcut to that, right? So I don't have to say this.cards.stream collect. I can just say this cards collect, pass in a collector. I'm doing the grouping by counting, and this is effectively the same thing that the JDK and Apache Commons did. And now we're going to deal some cards.
Do you want to skip this slide? We have just 6 minutes.
Okay. Dealing cards is fast. Little memory. Okay, so when we deal cards, what we're going to do is return an immutable list of sets of 5 each. And what you see here is we're going to take a stack. And in the JDK case, we're using the recommendation for a stack. We actually use a deck. We use an array deck. We're going to pass in that deck the number of hands that we want and the cards per hand. And we're going to use create an unmodifiable list wrapped around calling in-stream range, map to object, where basically this is going to give us each of the hands, so we get the set. And then we're going to actually then return that as the list wrapped as an unmodifiable list. It's a mouthful. By the way, all this code is available online, and you can go see it and try it yourself as well. We'll have it at the link at the end. For Apache, it's pretty much the same except for that list utils thing, right? With Eclipse Collections, we have, instead of int stream, we have our own int interval. I do 1 to hands, so this is the number of hands I want. It's 1 to 5. Then collect up the sets of hands that I want. So this deal returns a set. And then because we are collecting over what's effectively an immutable int list in the case of int interval, that actually winds up returning an immutable list automatically. With Guava, similar to the JDK and Apache, except for we use a different collector. We're going to collect into the immutable list at the end. And then Vavr.
That's unreadable.
Well, I'm trying. It's interesting. Vavr's types are by default immutable. And what you see here is they actually have an immutable stack. And I think actually a bug on our slides here, I should actually change that. It used to be called stack in Java slang, and it has changed to just be list. So list, it's immutable, and what it means is we can't actually change it. So imagine you have an immutable stack, right? How do you push and pop to it? Well, every time you do an operation on it, you're going to have to get a new stack and the thing that you popped off, right? And that's what you see is actually happening here. Every time we do something, we get back a tuple 2 of the thing that we wanted, and then we have to keep passing in a new copy of the stack effectively, right? So this was kind of hard to reason about at first, and to think it's like I just want an immutable stack, or a mutable stack, but I used what they had available.
Yes.
Yes, I did. That is not my code.
So to repeat the question was, do they have methods with underscore in their name?
Yes. So tuple 2 does have an _1 and _2. We also have like a pair. We just call it get1, get2, but that's a naming convention. So they went with _1. So okay. With that, we have this comparison table. This is what everybody wants to know. It's like, what's the best framework for me, right? And of course the answer is, well, that depends. What are you looking for, right? And what you see is that we tried to weigh things across the frameworks based on features that we thought were interesting. And then we tried to rank what we thought were, for each of those features, the top 3. So if all you need are list, set, and map, JDK is great. Use it. What do you need anything for, right? It's got a lot of functionality, especially now with streams. If you need bags and multi-maps and bi-maps, well, there are frameworks available that can give you those, right? You've got Apache, you've got Guava, you've got Eclipse with those things. You need a stack. Well, you can use deck if you want, or you can use immutable stacks from Vavr, or you can use mutable stacks from Eclipse Collections. You need trees or tries or tables. These are available in certain frameworks, not available across the others. But if you need things like immutables and primitives and a really fluent API, it really, once again, depends on what you're looking for, and you can kind of see what's available. And we've kind of ranked. We've got green check marks for yes, red X's for no, and then green check marks in boxes for kind of, and then the orange X's in the boxes for not really, right? So 4 state checkboxes. Those are awesome, right? All right. So anyways, that's kind of the talk, and we can take some quick questions. But here's the link to the source code if you want to check it out. And there's multiple implementations out there. There's the immutable sorted set implementation, which we used in our DevOps talk, and the ImmutableList one, which we've done today. And you can kind of see what the code looks like. And I would experiment for yourself. The thing's out there. Try it for yourself. Try different data types. If you want to measure it, if the performance is interesting to you, you can use the JMH benchmarks, and you can use the Nashorn object size calculator if you're curious what the memory footprint of something is. So
Yeah, so including our performance benchmarks, our memory tests, everything is out on that repo. We'll be pushing these slides out on the Java 1 speaker deck as well, so they would be made available as well. Along with that, we might put them on SlideShare. But if you have any questions, I mean, I know we are almost out of time. If you have any questions, you can always tweet to any one of us, and we will start redirecting who is an expert in which collection or in which framework, so to say. And we'll be here at Java 1 downstairs in the developers lounge area, as well as tomorrow around there. So if you have any questions, you can just tackle us, and we can talk more offline.
And I think, I like to echo what Leo said before as well, right? All of these frameworks are open source. If you're going to use them and you like them, as someone who, maintains an open source framework, I love when people contribute the things that they need, right? Yes, it'd be great if I built everything that you needed for you. I've built most of what I needed, but if you need something, it'd be great, really appreciate the contribution, and we're here to help you do that, right? It's like, you want to do that, we can help you, in GitHub, in terms of doing the coding, getting code reviews, and actually getting your contributions merged into the repo. So.
And contribution is not just by code. If you find a bug or if you want a feature, please do request us, because for Eclipse Collections 9.0, we had a ton of user requests, which we ended up accommodating, and users other than Don. So we do look at that, and we like it when our users tell us to improve the framework, because we can't reach the whole spectrum of our own code. And do not forget to vote. I'm totally fine if you downvote us, but just come back and tell us why you're downvoting, because it will help us improve our next talk.
Yes.
Again, we won't take it personally. Don't worry about it. Yeah.
We will say that.
And thanks everybody for attending. Have a great Java 1. Yeah.